Here's another one. It's only because I've seen it before. There's no trickery involved in it, really. I can't plug in 0, obviously, in this one, and because 0 makes the denominator 0. But I can still do my old step 1, which is plug in 2 values, one above, one below. So I'm going to choose my 2 values that are close by 0. I'm going to choose, in this case, they call it t. They're being clever. Let's put t equals 0, 0, 1, and then take something on the opposite side of 0 to the left. So I think of a little number line like this. Choose something to the right and to the left. Here's 0. So I'm going to take negative 0.001. So let's plug that in and see what happens. So I just made this for you for the other problem. I'm just going to change the function and the values to the right and left. So we can just go over here and go x, y, and then I'm going to put 0.001 and minus 0.0001. It doesn't matter. And I'm going to plug in into my function, and I'm lazy, so I'm just going to copy and paste that function. Like that. So let's put it here. That's equal to square root of d2 squared plus 9 minus 3. And then that whole thing is divided by t squared. Oh, it's not t squared, d2 squared. This is how you type it in Excel. And I get 0.166. That's a fraction that we know. And let's just do this. Let's scroll it and see if we get the same thing. Yeah, I get the same thing from both sides. So what is 0.166? I'm not sure because I don't play with my calculator enough. And what I get is 1/6. So this is 1/6. You can experiment around and see what it is on a calculator. So it looks like for both, answer looks like 1/6. All right, that's valuable because to do it by hand is a bear. Here's how you do it by hand. So let's take this guy here. Step 2, you have to I said factor before, but algebraically manipulate is what I should have said. And in this one, you remember getting radicals out of the denominator. Those are the terrible problems that you used to have in pre-calc. We're going to get the radical outside the numerator this time. So I'm going to take this square root. Don't put limit in front of it. That's one of the things that irritates me because you're not taking a limit. You're doing algebra. And I'm going to multiply top and bottom by what we call the conjugate. So I'm going to take the first guy, t squared plus 9, and then add 3. And the bottom, I'm going to do the same thing. Now, why would you do that? Well, because we're math and crazy, kind of. If you remember, there's a formula that says a squared minus b squared is a minus b times a plus b. Difference of squares. Totally easy. But if I reverse it, I have a minus b times a plus b is equal to a squared minus b squared. That's not usually the direction we look at this, but that I'm going to use that. Because if my a is this god-awful t squared plus 9, and my b is this god-awful 3, really what I have here is a minus b and a plus b. So I know what the answer is without doing the multiplication. So I'm going to pull this over to the other side. Let's do a new page. Copy. Paste. So the top, I don't have to do the math. It's going to be a squared, which is the square root of something squared is itself, minus b squared, which is 3 squared, which is 9. And the bottom has the, just keep it together. Don't distribute in. So the 9's cancel, and I'm left with t squared over t squared times square root of t squared plus 9 plus 3. And then these guys cancel. And I just have a 1 on the top now. So that's equal to 1 divided by square root of t squared plus 9 plus 3. And now I can plug in 0. So I get 1 divided by square root of 9 plus 3, which is, voila, the answer I got with the number is exactly what I get here. Pretty cool.